It could be your router, your network, you just disable Wi-Fi, enable Wi-Fi, and things like that, right? Now, how many of you are familiar with the home networking? Or let's say you talk to the Comcast or Xfinity or any internet service provider and say, I have this problem, help me out. Has anyone done that? Okay, so you have some. So do you all have internet at home? Yes? Okay. How is the internet coming? Who is the internet service provider?
Company.
Which company? Xfinity is one of the one. Verizon, AT&T. So these are all the internet service providers. But how exactly is it working? Like, let's say I just moved from California and I want to look at some of the fastest internet service provider near me. And I'm asking class, and most of us are saying Xfinity or Verizon. And then I'm deciding, okay, now let's call Xfinity, right? And then I call the Xfinity. What are these guys going to tell me? I have this package, I have this package, I have this package with this speed. These are all the benefits. You get the phone, you get all these different things with it, right? All these different variations. And then I decide, okay, this is the package that I want to get. So let's say Xfinity has given me a package. Okay, and they said, this is your home network. Anything that you do inside is you're responsible. And then what we have is outside. Okay. Now, very first terminology that we are learning today is anything outside that we do not control. Can I say that is internet? Yeah? Can I say internet? Anything that is giving me connectivity from outside, I'm just going to simply give it a name called internet. And then anything inside, the technical term is intranet. Okay. So if it is outside, so let's say I'm going to call this instead of home, I'm going to say this is inside network. And this is outside network. Now, when you are let's say you are in a company and you are in a group call, and then these folks may say, hey, this is just the intranet, this is inside network, that is outside network. We usually call them internet or intranet. The other very famous name we also have, this is LAN, local area network. And anything that is outside, we usually refer to that as WAN, wide area network. Now, depending on which company that you are working for or who you are talking, some of the networking folks or somebody who is not very familiar, we simply call them inside network, outside network. Very technical terms, we call them LAN or WAN. We can, in general language, I'm pretty sure that most of you have never heard of this intranet. But we all heard about the internet. Intranet is something where we control. Internet is something that we do not control. Now, how do you describe internet? How do you describe internet?
Connection.
Where I can watch YouTube clips?
Like connectivity?
Connections, connectivity. So internet is nothing but a network of networks. Network of bunch of networks working together. In simple term, internet is described as network of networks. Yes, you had a question?
Yeah, I wanted to ask, so when you said intranet over here, like the local area network, is it?
This is intranet.
Intranet, yeah. So is it like your ISP, your internet service provider, or that's the company's?
So in our class, all of us are connected to one network, right? The network we said is front right. Is that true?
Mm-hmm.
Okay. And then this is a router. And then all of us has the Wi-Fi connectivity to it. Right? So we have systems here. We have a bunch of systems here. You all are connected to the router. And then I also connected, my machine is wired machine here. But here, this is going outside world. And here what happens, we do not know. So this is internet. Right now, inside anyone who is connected, we are intranet. Does that make sense? So this is a simple example. So I pick up the phone and I say, hey Comcast, I have heard some good news about you. I'm looking for a bunch of, I'm looking for an internet at my home. And they say, okay, yeah, we have a bunch of these packages. Which package that you see? Which package that you want to have? And I say, okay, give me the $50 package per month. Fine. They say, okay, no problem. Now I have two options. The first option is where you can buy, where we will come to you and then we will do the installation. That is going to cost you $200. The other option is, I'm just going to ship you a bunch of boxes, wiring, and then just a bunch of instructions. You follow it, and then you are online. That will cost you $0. Now, I would say, okay, you know what? This is my intranet. And here's my internet. So I will say, okay, since I want to save $200, I will just ask them, hey, just send me the package, right? So now, if I start looking into the wall, they said, can you look into something on your wall that looks like a port where you can connect the internet wire, which is called the Ethernet cable. And you start looking around and then you say, yeah, so anything here is my home, anything outside is not my home. I don't know how that works. So I say, yeah, there is a connectivity here. And you say, okay, they said, okay, I looked at your home address and we already have the ground wire connected to your home address. So we are going to ship you. Now, when they ship you, you immediately realize that they have shipped you a couple of boxes or just one box here. And they are going to call this, whatever the machine, we are not getting into the technical terms. All they're saying is, just connect this wire here and then connect this wire to your laptop. How that works, we are not worried about it. And then all of a sudden, you are online, and then you are happy, right? And then we ask them, hey, you know what exactly is this? And this guy say, oh, it is called modem slash router, but you don't have to worry about it because you already completed here, and then you got this one here. Now I'm a little curious, and I said, hey, let me start looking into this. What exactly is behind this wall that is connecting to the outside world? When I start looking into this, I realize that this wire is connected to my apartment building. Outside, there is a big machine here or something that I do not know what it is. And then from here, it is going all the way to the Comcast office building. So let's say this is your Comcast office building, Xfinity office building. And somehow it is getting connected here. Now, in between, there could be a bunch of stops here. Let's call them. Let's say this is the train. There are a bunch of stops here. Now, all the stops where your connectivity is stopping, we want to call them hops. So this is from my laptop to this machine, this is a hop, your first hop. Then from here to this, it is another hop. From here to here, this is another hop, another hop, another hop. So if you start thinking in terms of how we are getting there from point A to point B, there are a bunch of middle stops in here, and in technical terms, these are called a hop. So your connectivity, your packets, and then we will talk in details about it. It goes into one stop, that one stop does something, then it goes to the next stop, and so on. And then finally, it reaches here. Now, if the connectivity is happening here, and then my machine is happy because now I can browse, I can Google around and everything, how exactly is this happening? So I'm a little curious, then I start reading. One of the articles that I have read, it says, hey, your Xfinity guy here, which is your ISP, Internet Service Provider, is basically leasing you an IP address. What exactly is an IP address? Then I start looking more into the details, and I realize that humans uses a phone to communicate with the other human. Okay? Machine uses an IP address to communicate from here to here. Now, if I start looking into the phone numbers I have for America, let's say I have the first 3 digits as a zip code, right? The next digit, 3 set of digits are some zone, and then you finally have your actual phone number here. So the phone number in US, it is designed to have 3 different sections. Yeah. So here we will say 773 is the area code, 440 is some other code, and then I finally have my phone number. Similarly, if I start looking into this is my phone number, and then I have the IP address. Now IP address, there are 2 different IP addresses. There is one which is called version 4, which is the most famous, and this is the one that we are going to focus on. And then there is something called version 6. Now version 6 is also active, but majority of the companies are not there yet. So we are going to focus on the version 4 of IP addresses. The version 4 of IP addresses, the rule is you have 3 numbers, and then you have a section. This section here is we are using the dot in between, and then there are a set of 3 numbers. Then we put the dot in between. Then we have set of 3 numbers again. Then we put the dot in between, and then there are 3 numbers. Okay? Can I say that? Okay. Now let's say each of the restriction here, each of the number, the restriction here is you cannot have any number bigger than 255. So I have the 255, 255, 255, and then 255. Does that make sense? Okay. Now, let's say in the world there is only one computer. Guys, this is very important. So I would rather stop and listen, right? So do not type or do not write anything. Listen here. Let's say on this planet there is only one computer, and then it has to follow this rule. Okay? Then I will say, my first computer is just 1. All of these, I'm just going to put the 0, 0, 0, 0, 0, 0, 0, 0, 0, and then 0, 0, 1. Imagine that this computer is the only computer in the world. So can I say this is a valid? So maybe what I can do is I can reduce these zeros here, and I can say computer 1, you have the address of 1. Imagine you have a 1 phone number on the planet. So can I say I don't need all these different parts? I can simply say you are number 1. Yeah, there is only 1 phone on the planet. I have 1 IP address on the planet. Then the IP address will start growing. So imagine. So I have the first IP address, the second IP address, third, fourth, fifth, sixth, seventh, right? All the way up to 255. Then I say, okay, there are only 255 systems on the planet, and this last part is good enough for that. Now I have a 256th IP. But the rule says I cannot go more than 255. What do you think I have to do now? Can I go here and I say, hey, now I have 1.1 all the way up to 255. So imagine 256 computer. So the first part is I can only have 1 to 255. Is that true? Mm-hmm. Okay. The next set of computers, then I have 1.1, 1.2, 1.3, and then 1.255. The second set, now once I'm done with this one, can I say I need more computers? So maybe I can say I'm going to, so 1.1, you are done. I'm going to start with 2.1, 2.2, 2.3, 2.4, and then up to 255. Now the second network of 2 is also done. Then I can start the network of 3. 3.1 all the way up to 3.255. And then if I keep going here, at some point I'm going to reach 255 here. Yeah? If I reach the 255, again 255.1, 255.2, all the way up to 255.255. What that means is, I have started 1 here, and then I went to 2, then I say 3, then I say 4, and then at some point I'm at 255, and then the max I have is also 255. What do I do next?
You go to the next segment.
Next segment. Now if I start looking into this, then I will say I'm going to start with 1 here. and then 1.1, so 1.255.1, 2.255.2, 2.255.3, and so on. Can I say it is going to keep increasing? So here, if I have this IP address, for example, I have an IP address of 10.14.16.100, or let's say 1. And I'm going to say, this is my network called MOID. Okay? How many systems a network called MOID can have?
How many systems?
How many systems? How many different IP addresses that I can have?
Just one?
Just one? But I say this can start from 1 and then it can go all the way up to 255. So how many IPs that I can have? 255. Because now, can I say, is this a valid address? 10.14.16.1. Is this a valid address?
No.
No?
Yeah.
So 10.14.16 is my network.
Oh.
I'm going to define this as network A, right? Let's say this is network A. True? Then can I say if this is the first IP, then can I also have the second IP?
Yes.
I have my laptop as 1, my desktop as 2, my some other machine as 3, my other phone as 4, and then how many I can have?
255.
255. And after this, if I still need a new net, if I need more computers, what do I have to do?
A new connectivity has to be established.
Now, remember, the network A is this box. This box can only have 255. So do I have to create a new network?
Yes.
Okay, what is that network now? 256 you cannot have, right?
It would start with 1 again.
One dot.
10 dot, 14 dot, can I say 15 here?
Yes.
Yes.
Yeah, so 15 can have all the way up to 255. Okay, so this becomes the network B. So here, let's say this is network A, this is another network now. Now if I need more, what do I have to do?
More as well.
So this network can have 255, right? This network can I also have 255. If I need more IPs, what do I have to do? Make a new IP address, or can I say make a new network?
Yes,
You need that word.
So what do I mean by that? Can I say 10 dot, 14 dot, 14?
Yeah.
Or also, can I also increase 10 dot, 14 dot, 17 now?
Yeah.
Yeah. Do you see how each one of this is having up to 255? So 1 to 255. This is 1, it can go up to 255. This is again, right? Each network is going up to, from starting from 1, and then it is going to have 255 IPs.
So is that up to us how much we can add it?
In what?
So it's like up to us how we can add it. Like
Can I say I can go to 13?
yeah.
Can I go to 12? Can I go to 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1? Can I say that?
Yeah.
Each of this, so at this point, I'm saying, okay, now I have to start increasing because now I was going backwards. Now I can start increasing. So 14, 15, 16, 17, 18. Can I say 200 is another one number? 225 is another one. 254 is another one. And then 255. Can I go with 256 again here?
No.
No. What do I have to do then?
We have to start another.
Another network. And what is that network? 10 dot? 13. Exactly. So since 14 is fully covered, you start from 1 and then it went all the way up to 255. So the next network would be 13. If this network is all full, the next would be 12, right?
Oh, yeah.
And then 11. And then once I'm full with this, so let's say this went all the way up to 1, and then this number went all the way up to 255. Then the next network is what?
10.
10 is already covered, right? So now I have to start with 9. And then this can go all the way up to 1. And then finally, the first set can go up to 255.
So why we can go till 255? Why we cannot go more than that?
Yes, that is a good question. Remember I said the version 4? This was developed back in 1940s, 1950s, 1960s when it came to the production. So the first IP address was version 1. Okay, it never came to the production. They were still researching. Then number 2, then version 3, then version 4. So version 4, when it came out, the internet there was no internet. That was intranet time that time, like long time ago. IBM. They only have set of machines on their side. So what they did was they said, okay, how many IPs do you think a company would need? 5, 10, 15, 20, 200, 2000 IPs. Not more than that. So when they designed the version 4, they said, if we go with this one, we are going to have good enough IPs. Good enough IPs means 255 times 255 times 255 times 255, you can have up to 4.2 billion IPs. Okay, 4.2 billion IPs. So back in 60s, they never imagined the computing world would have that many IPs in use, because remember that time there were only corporate computers. There were no personal computers. In early 90s, something really major happened. What was that? Can I say internet? Internet came in 90s, and then after that, almost everyone will start having PCs, and then it went further step. Then we have the cell phones, then we have the smart gadgets, and so on. Now, at this point, do you think 4.2 billion IPs in the world of 8 billion people are good enough?
No.
They start realizing this in 1998 or so, and they said we have to come up with a new set of IPs, a new version of IPs. And they start working on the next generation, of IPs, which is the version 5. Now, version 5 never came into the production. And then the version 6. Now, version 6, how many IPs can a person have? Or how many IPs do you think the world can have? What they're saying is how many people do we have on this planet now? 8 billion, right? 8 billion. What they're saying is every person on the planet, if they own 50,000 IPs, we will still not run out of IP. So you own 50,000 IPs, you own 50,000, you own every single person on the planet. If they own 50,000 IPs, they will still not run out of those many IPs. So if you start looking into this, 840, these many billion IPs, the IPv6 can offer. And we still do not run out of IPs. Okay, so the formula that they have, so I'm not going to teach you more on the version 6. We are only going to talk on the version 4, because majority of the companies are still using the version 4. Maybe 20 years down the road or 30 years down the road, maybe they'll start using the version 6, but version 4 is working perfectly fine now. Does that make sense? So I'm going to tell you a little bit more about this now. How does the IPs work now? So before we get into more details, where you will have better understanding,
So, sir, the version 4, the number of IP address, they have only 255.
No. We will talk more in detail. So give me few minutes, okay? So here is your ISP building, like we said earlier, right? And then they have rented you an IP. Let's call this IP as 11.12.13.14. Now, knowing what you know now so far, can I say an IP address is a set of 4 numbers?
Yes.
Yeah? So IP address properties, IP version 4 properties, right? Set of 4, and each set here can have a minimum of 1 and then a maximum of 255, right? Each set and each set is, in technical terms, we call this, in plain English term, we call it set. Each set is called the octet. Okay, so now I have each set that can grow anywhere between this and then it has to stop at 255. Okay, so it will start somewhere here and then it will have to stop at 255. Same thing here. Okay, so the maximum number, if you start looking into this, the maximum number of computers in this world that we can have with version 4, or not, maximum number of IPs are 4.2 billion. Minimum number of IPs is 1. Can I say that?
Yes.
The more that I need, I better have to start looking around and then start making a network. So at this point, do you understand this better? So IP is the Internet Protocol. IP is Internet Protocol. Now, how do you define the word protocol? What is protocol? Set of rules? Yeah. So here, protocol is nothing but set of rules for networking. And V4 is the version 4. Okay. Version 4 offers 4.2 billion unique IPs. Versus, if we start looking version 6, what we have seen is it offers 400,000 billion IPs plus. Okay. So version 6, which we are not going to talk about, version 6 will offer you 400,000 billion IPs. Okay. Now, if my ISP, which is the Comcast guy here, they have given me one IP, 11, 12, 13, and 14, right? So now if I look into, if I say Google here, google.com, google.com will work here. Okay. Now this person here is a little curious and he says, okay, since I know a little bit more about the IP addresses, let's find out what is my IP address. Okay, let's find out what is my IP address. Now I want all of you to open your browser, Google Chrome or Internet Explorer, whichever that you have, Firefox. And I want all of you to type, and if you are on my network, I want you to type, what is my IP.com. What is my IP.com? What is the IP that you see here?
98.212.
Okay, first of all, when we are talking about IT, right, there is no point. Everything is a dot. Okay, so we have to say, so the IP address that is given to us from our Comcast is 98 dot. What did you say?
212.
212.42. Dot 42.
Dot 100.
Dot 100. So are you all seeing the same IP address here?
Yes.
Okay. So what is my IP.com. If I start looking into this, if you start looking into this, this is the IP address that is given to me from the Comcast. Now, if I start saying the Comcast, hey, google.com, and then what is my IP, it tells me that 98.212.42.100. This is how you can find out what is the IP that is leased to you from Comcast, from your ISP. ISP is nothing but your internet service provider. Okay? Now, once we know what is the IP, that this is the IP that is given to us, now let me ask you this. Let's say this is your home's intranet, and now you have your neighbor's intranet. Right? And then they also have, Comcast is also renting another IP here. They have bunch of hops here, and this, using this hops, Comcast is actually renting an IP here. What do you think an IP would be? Can I say it will be same IP, 98.212.42.100?
No.
What do you think the neighbor will get?
101.
101. Very good. So 98.212.42. Either 101 or 99 or 98 or 243 or 217 or 255 or 273. Are they all okay?
No.
Except the last one is beyond the protocol. That protocol is not working. The rule says you can never have 250 up to 255. So if I have 100 and they have 101, that means somebody also has 99. Somebody also has 98. It went all the way up to 1. Does that make sense?
Yes.
So no two houses, no two machines will have the same IP address in the network. So they have leased me this $50. They have leased them this IP, and then they are charging $50 for this one. Every single IP they are charging $50. Make sense? Okay. Now I'm going to remove the neighbor's internet here, and let's say I have a need. Okay, so this is what I'm paying right now, and if this is what I'm paying, right? I'm the only single person living here, everything is all connected, and I'm happy. Now I have another person who wants to connect to my network. So then what I have to do is I have to disconnect and then connect him. And this person is happy now, and I am sad. Why? Because I don't have any internet and he has internet. And then, but we are still managing somehow. There is another third person who is living in the house. So this third person, I have to disconnect here, and then I have to give him the internet. So this person is unhappy, I am unhappy, but this person is happy now. Because he has the internet, he can look into his email, banking, and so on. So I said, okay, you know what, this is not going to work. I better call the ISP, which is my Comcast. And I say, hey, you know what, I have 3 machines, and at any given time, 2 are down and 1 is up. There are 2 people who cannot connect to the internet, 1 person who wants to connect to the internet. And my Comcast guys say, oh, you know what, no problem. What we'll do is, we'll give you another dedicated connection, which is going to connect to your hop. But now I have another one here, and then you have another same machine here, and this person can connect here, and he is happy. And then I'm going to give you another dedicated connection here. This person also has this machine, and then he can connect here. And I was like, oh, you know what? That's good because we all are happy now here. All three of us are happy. But the problem with that is, I'm going to charge $50 for this one. I'm going to charge $50 for this one. I'm going to charge $50 for this one. So although I have 3 dedicated connections, one is getting 100, so the other person is getting 101. The other person is getting 201. As long as they are different, I'm happy. So we all are happy because we have our own connection. But it is going to cost us more money. Yeah? So there is another salesperson. This salesperson will say, no, don't worry about it. There is a simple solution. That simple solution is you just add a router to your network. Now, what exactly is a router and how does that work? Let's take a quick look at that. So Comcast has given you 100, right? This is my IP the Comcast has given to me. So maybe there is half here, there is a half here, there is a half here, and then finally it reaches my network. So this is the IP. What they're saying is you have to connect to a box here. Okay? This box is called the modem. And then from this modem, what you have to do is you have to connect. You can either buy a router, which you can get that for another $50. If you just go to Best Buy or wherever you want to go to, get another router. What exactly is the purpose of the router? A router will take one address from outside and it converts that into a network of addresses. What do I mean by that? So can I say, router, this is WAN, wide area network, okay, because this is coming from outside. Remember, anything outside is WAN, anything inside is LAN. So here I'm saying this is connected, so it is going through the modem. By the way, does anyone know what is modem? What is the main functionality of a modem?
It gives connection. So, like for instance, when you see your Wi-Fi neighborhood, you can connect to it.
But I can. So, is it necessary that I need to have a modem?
Yes.
Why?
Because other people can connect to it. Like maybe
Because if you don't have the main IP address, you cannot connect the other IPs.
Okay, so main IP address is also already given to you from the Comcast, right? But what if I say I'm going to remove the modem and I just connect directly to the router?
You cannot because you need direct connectivity.
You need the. So let's say what they're saying is this is the cable wire that is coming to your home, and then you have the port, and then last time you were just using the modem, but this time you can simply connect to the router. Is it going to work?
That shows your video the ones we
Your primary network has to be through the modem.
Okay. My primary connectivity has to be through the modem. But what if I say I don't need the modem? I can just connect to the router and it will still work. Now, is it possible or not possible? We'll look into that later. But what is the primary focus of the modem?
The local area network has to be established.
I can do that from router also. I can start. So this IP is basically handed to me. Remember, what is the purpose of the router? Okay. Purpose.
But the router has to take the address from the established network, first of all.
So established network is here. So I have the WAN connectivity directly connecting here. And then you have the local area network connectivity here. So purpose of router is take one IP from ISP and assign set of 255 IPs. What do I mean by that? You can take one IP from here and then the router's job is to route. So I can have multiple IPs in here. But again, let's not forget about the modem. The main purpose of the modem is to convert the voice into a text and text into a voice. How many of us are using YouTube? Is there a sound that is coming from there?
Yes.
Yeah, sound. What about the phone calls? Voice over IPs, Skype call, anything that is connected through the network. So the main purpose of the modem is to convert your sound into the binary code, and then the binary code is again converted into the voice. So for example, if I'm in India, I'm calling, right? My service provider, the modem is converting my sound into binary code, and then the person in America who's receiving it, they're receiving that in the binary code, and the modem on our side is converting it back to the sound. Okay. Now what they are doing is they are converting, they are mixing pretty much in the last 5-10 years. Now what I'm saying is your Comcast or your Verizon, everyone, they're just assigning the modem. It is either a built-in modem or not. So for example, on our phone, we have the built-in modem. We have the modem and cable. What they're saying is basically they're saying I can get you all these different things, sound, pictures, music, brilliant colors with high speed, with a combination of a cable/modem, but they're not giving a router. Starting last few years, one machine is good enough. It has the modem, it has the cable, and it also has the router. But let's say we are still on the old technology and then they give you the modem. Now, I'm not really worried about this because I'm just thinking that as another hub. Remember how we have different hubs here? I'm seeing that as a hub. That hub is assigning my router the IP address, which is 98.2.12.42.100. Router is taking this one address, and what it is doing is it is converting that into a network 192.168.1.1. This one dot network can go from 1 all the way up to 255.
So basically, the router it assigns multiple IP addresses.
It takes one IP and then it can create one set of 255 IPs, or it can create multiple set of 255 IPs.
Okay, I gotta ask a question. So like, do you have a router or modem here I could see physically?
Yeah.
Okay, I just want to see like how it is.
Okay, we will look into that. You mean the router configuration page?
Like just like for instance, like what you're saying, like for instance, the modem and then the router.
Yeah, I have two pieces here. The white piece here, if you want to stand up, the white piece here is the modem, right? And then the black piece here is the router.
Wait, over here is the modem?
Yeah. So this is the modem, right? And then this is the router. So it gives me the IP that you are seeing here for 98.2.12.42.100 is the IP that is given to the modem. Modem has simply is doing its purpose, but it is connecting to a local router. Local router is routing an IP address to each of you. Okay, and I will tell you how we can see the local IP address. The one that we have seen so far is the outside IP address, but I will also show you how we can see the local IP. Local IP is separate IP for all of you. Now, any confusion with this so far?
So I have one question. When you create the router IP address, you're saying it can be spread into, but why is 3 digits? Usually you're saying
No, 4 digits. This is my fourth step. I'm saying
192 and then 168 and then should be one more and then the last one is.
Yeah, so this is the first octet, this is the second octet, this is the third octet, and this is the fourth octet.
Oh, okay.
Yeah, so there is .1 in between here.
Okay.
So 1 is also a valid, right? So can I say this is a valid address? 172.15.1.17. Is this valid?
Yes.
Yeah. So this is the network, and 1 is assigned to someone. And then 255 it can grow up to 17 is just 1 in the center. Does that make sense?
Yeah.
So I have 4 octets here. What I'm saying is it has taken one IP from outside, right? Which is the public IP. and it is assigned a set of private IPs that can go from 1 to 255.
I guess the octets would always be by default 4 segments.
Exactly. With
The
the
integers assigned on each of them.
yeah, and it can never be a negative number. Okay.
Sir, we can choose the router gives the different number like 192.168.
There is no point. It's always talk about dot. Okay. So what is it?
Sir, we can say like the router gives the number like 99.
A network.
Okay.
This is called a network. So here it is creating a new network of 192.168.1 that has the IP address capacity that can go from 1 to 255. This is the one network. If I need more IPs, then it will create another network. I can create another network, 192.168.2, right? And then this can assign from 1 all the way up to 255. Yeah, so the first network and then the second network. Now this second network, how far it can grow? 192.168.3. 255. How far it can grow?
Yeah.
Right, so this is 3, this is 4, and then this is 255. 255 will again from here to here. Now if I still need more IPs, what do I have to do?
Start from, yeah.
So this is another network, right? So my next network would be 192.168. Is that 168?
67.
67, or next one is the 69. And then it will start 1 here again, and then this will again start the whole series. The next one that I need, 192.169, and then this would be 2. That will start 1 all the way up to 255. And how far it can grow? This one, 255. And then once I'm done with that, what is the next IP in the list? Next set. 192, 170, and then 1 will start again here, and then this will go from 1 to 255, right? And then the max it can grow is 255. Then once I'm done with this, the set of 193 will start. 193, 1.1. And then you will start from 1 to 255.
Sir,
Do you see how it is keep incrementing?
Sir, my question is that it will start from 192.
No, I just gave a random number. Okay, and then there are some industry standards that I'm going to tell you.
And sir, like last number, you always like put in 0.1.
Dot 1.
Sorry, dot 1.
Yeah.
So
this is the lowest number, right?
yeah.
So one network can grow from 1 to 255. Okay. And then I'm going to tell you some rules about this IP address allocation as well.
So
I'm just giving you a wide picture now.
So we can change like in the middle of the number, like before it was 168. So we can put now 169, and either we can put 170 also.
Yeah.
So it,
Now before this one, can I say it was 192.167.1. The network of this. Right? This is 168.1. So before that, it is 167.
so sir, after the 67.1 and 1 point, what we can put another number?
1.1.
Dot 1.
Dot, right?
Yeah.
I'm telling you, if you are talking to any IT person during the interviews and etc., and if you say a point, they know right away that you are a beginner. Okay, so let's try to get into the habit of saying dot now. No more points. Again, ask your question again.
So like after the 1 dot, so we can write any number like 2, 3, 4, anything.
This number is in here, you mean?
Yeah.
Yes, you can give any number that you want, and I will talk more about this in a few minutes.
Between 1 to 255, we can put any number.
Any number. But again, there are some rules. I'm going to talk about those, and based on those rules, we can start talking.
Just now, so out of the 4 octets that we have, right, and these are segmented, can we say the first 3 set of octets are identifying the networking, and the 4th one is the one identifying?
Not always.
Not always.
So in this case, the first one, in this case, the first 2, in this case, the first 3.
Okay. but the fourth one is always the end user who is using it.
Correct.
That's my question.
Yes.
So the fourth identifies the end user who is assigned the specific protocol.
Yes. That's the machine number.
That's
So,
the machine number.
yeah, so that is the number that is given. So in our case, remember how our home phone numbers are? So we have 773, right?
Yes.
8407933. This is your actual end number.
Exactly.
So here, this is also your end number. So for our Comcast, this is customer IP. But internally, what we are doing is we are creating a set of IPs. And in these set of IPs, the last number is here assigned to your machine. Make sense?
In some of the work that I recently do, we go through investigations of the federal cases, and they catch, law enforcement agencies, they catch a lot of predators based on the IP numbers.
Yeah.
They found out exactly the laptop that I used to download the information based on that number.
Now, I'm glad that you said that. For example, you come to my office right here, and then you last octet that you get is 73, for example. You get to Starbucks, and then you use the free service there, and then the last octet is 191. You go home, and the last octet is 10. You go to some other mall, the last octet is 203. Now, based on this, how is let's say somebody is after you, right? So based on this, how are they going to find that this is coming from your machine only, not someone else? Because the next day that you go to the same places, the first place you went to, you have .3. The second place you went to, that you have .202. The third place, .17. The fourth place, .53. Every day your IP is changing. So how are they going to catch you if you are doing some nasty work?
Because they will look the full configuration of who was assigned initially that number. So the 73 would be used for Starbucks.
Let's say somebody, if police authority is looking for somebody, they're solving a case, and this case was done 3 years ago. Okay, and then IP's address has changed since then. 300, 3 years ago. So almost 1,000 days ago, right? So there are a lot of new allocations, IPs, and so on. So my point is, can a human have a different phone number?
Yes.
Yes. If I go to California, they may have a different phone number. If I go to Russia, I have a different phone number, right? So similarly, if let's say you are a U.S. citizen, you are in U.S. Can I say a social security number will never change?
Yes.
Yeah, is it possible? But the phone numbers can change.
Yes.
House numbers can change. Home addresses can change. But most likely, the assigned social security number that is given to you is going away only after your death. Similarly, the IP addresses can change, but there is something else that is called MAC address. MAC address is your social security number of your machine. It will never change the life until you actually change either the Ethernet card or your computer. So when they are tracking, they are not just tracking the IP address, they are making the correlation between the IP and the MAC address. That's how they are catching it. So IP address will always change. I go to some other location, the IP address is changed.
Could they ping your device?
They can do many things.
Okay, but could they ping it without having the MAC address? Could they just
No, every machine has to have a MAC address. Otherwise, they are not on network. And I'm going to show you how we can do that. Now, again, let's go back to the topic. You understand the ISP is giving you one IP address. Are we all okay, or anyone has any doubt? Now imagine if I own a company called ABC, I can only have one number that is coming from outside, but I have different extensions for each of my employee. Extension 1, extension 2, extension 3, and so on. So the same thing, your ISP is giving you one IP, and then inside, when you use the router, your router has the capacity to take one IP address, that is the WAN address, and convert it into a LAN IP addresses of up to 255. Make sense? So one phone number, I can have up to 255 extension for all my employees. Similarly, one IP address, and I can have up to 255 systems with each unique IP address. Make sense?
So the MAC address for Starbucks would be something which is in the machine.
No, MAC address of not MAC address of Starbucks, MAC address of your machine.
That,
I see.
Yeah, and then I'm going to show you how we can see the MAC address as well.
That's what you meant by machine when you use the term machine.
Yes.
That means which is the device I'm using on my end.
Yeah, so that machine could be a laptop, your phone,
Yes.
your anything that can go online, any smart device, right?
Mhm.
A smart fridge, smart cameras, a smart anything, smart TV, and so on. So here we have the router. Router uses this port here, is called WAN. This is where your cable connection will come. So router is taking 98.212.42.100. Is that right?
Yes.
But internally it is converting it to 192.168.1. a network. This network can grow from 1 to 255. Is that true?
Yes.
Okay. The technology that it is using to convert this that one IP into a set of network is called NAT, Network Area Transition. Okay. So some of the keywords that we have learned so far: ISP, Internet Service Provider, IP version 4, right? And then IP version 6. And then we also talked about outside network. Outside network, and then inside network. Outside network is wide area network. Inside network is local area network. Outside network, in simple terms, we call it internet, right? And then inside network, we call it intranet. Okay? So internet is a network of networks. Network of networks. Network of public networks. Intranet is a network of local network. Okay. We also use the terminology called NAT. Okay. Network Area Transition. An example is Comcast is giving you an IP address of 98.212.42.100, and this is called a public IP. And then your router, who's sitting in between, it routes. So it is taking this into wide area network, and then local area network. It has started from 192.168.1.1 all the way up to 192.168.1.255. Now, router in general, it keeps one IP for itself. So number one, it uses for itself. Router keeps this IP for its own management. So first IP address it uses in general, not always. In general, it uses for its own network. Similarly, the last IP that it reserves for something called broadcasting. So what that means now is any IP from .2 to 254 are usable IPs. IP addresses. So how many usable IP addresses in total? 253. Yes.
Without the router, you can't have many. Nobody can connect to it.
Without the router, there is another device which is called a switch. I have not talked about switch yet. We will talk about it.
Okay, but basically, for instance, how we're all connected to the internet.
Then you need to have, again, everyone, all of you should have your own modem.
Oh, okay.
Right? $50 each, $50 each, $50 each.
And then one modem can connect to
one router. The router uses a technology called NAT, network area transition.
Yeah.
And then it spans a set of 255 IPs. Out of those 255 IPs, it reserves the number 1 for its own, and it reserves the 255 for broadcasting. That tells me that I have up to 253 IPs to work with. That means I can connect up to 255 computers, computer in the form of a laptop, desktop, server, media server, smartphone, smart printers, smart cameras. Anything that is able to communicate with the other machine is a computer, is a system. So I have up to 253 IPs to assign to different systems. Okay, so one is always reserved, and 25 or 255 is also reserved. Okay, so here reserved for router, and 255 here is reserved for broadcasting. It means I have set off another 253 IPs that I can assign to anyone.
Sorry, I don't understand.
Okay, so let's say you understand what is Comcast, right?
Right.
Do you have Comcast at home?
Yes.
So Comcast is giving you one IP address. So give me one IP, whatever you think. That let's say they are assigning this to you.
Like 190.
Okay, so you have a router at your home?
Yes.
Okay, so give me an IP address. Can I say 2.3.4.5? Can I say that they have assigned this to you? Yeah. So your Comcast has assigned you 2.3.4.5. Okay. Now internally, how many computers can connect? Let's say this is just the modem. How many computers can connect? One modem has only one port. It is not wireless. So can I say you are the only one who is connected here? Yeah. Now your brother comes in and he wants to use. What does he have to do?
No.
We have to get like router or maybe.
So in this case, let's say you don't have any router. You have this setup. You are happy. This is you, right? You are doing your school homework and everything. You're happy. Now he is coming and he says, I really have to get this test done.
So maybe
disconnect.
Maybe I have to disconnect, either he can use or maybe I can.
Okay, so you disconnected and he is using this one. And now you have to wait, and your brother is, even though he said school work, but he's actually watching a movie now. How would you feel?
Still.
So in this case, what is the solution?
You need a router.
Can I say that? Do we need a router, or do you want to call Comcast and get another modem for rent?
Router.
Router, right? So here what you are saying is, okay, I'm going to add a router in between, right? And here, now you put a router. What is the purpose of the router?
To spread like internet.
Well, the internet is already here. You are already connected. So router has set of ports. the first port it will always have is something called WAN. It always has a port called WAN, and it has set of ports. They are marked as LAN.
You said LAN?
LAN.
LAN? Okay.
LAN.
Okay.
So if you flip your router, you will actually see different ports. So let me actually see if I can find a router, and then we will see. Okay. Come on, Rain. So let's see this one. Do you see the yellow one there?
Yes.
I don't know if you can read, but it says internet.
Right.
That is WAN, wide area network. So your cable that is coming from the ISP is connecting here. Okay. And then here, if you start looking into this, these are the ports that are for LAN. Okay. So I don't know if this is clear enough, but let me see if I can find something better. I don't know if this is good enough. I don't see any labeling here, but the yellow one is where you are connecting from outside, and all these are the LAN ports. Okay, so now you got the router, and then your internet is connected here. Now your brother can connect here, and you can connect here, and you both are happy. But remember, one of the rule of IP is you cannot share your IP address. Everyone has to have an individual IP address.
Right.
So if I'm using this IP, who is going to use this IP 2.3.4.5? Either you can use it or your brother can use it. You cannot both simply use it, right? So it is getting the IP address 2.3.4.5 for itself, and it is converting that into an IP address, a set of IP addresses of 192.168 1 dot, and then it is keeping one for itself. It is keeping .2 for your brother, and it is going to give you .3 for you. The technology that it is using to convert this IP is called the network area transition. It is bunch of code to reroute the traffic. Are you clear now? So every network, how many IPs that every network can have? 255, right? So one, if it is keeping, the router is keeping for itself, it is not going to assign to you or your brother or anyone.
Right.
Similarly, the last IP 255, it is also going to reserve. There are two IPs that are going to reserve. Reserve 1 and reserve 2. Now what that means is I have .2 all the way up to .54. So how many set of IPs that you get here? 253. These are the 253 usable IPs. The reason I say usable is this is where you can assign to anyone. And then the first and the last one, it is reserved. Make sense?
Yeah. 1, 2, 3.
So I want all of you to use on your keyboard, if you start looking on your keyboard, there is a Windows key. Do you see the Windows key?
Yeah.
So here, there is a Windows key here. If you're looking at my screen, right? Windows and R. I want you to type Windows and R together. Press Windows and R together, and you will see a window like this. Yeah? So I want you to type CMD and hit enter. CMD, a black window will pop up. Now you can change the color of that black window. I keep it yellow to have it more visibility.
Excuse me, Professor.
Yes.
Someone's getting an info. Can we just click terminal or? This is specific. Let me go to
Somebody is doing what?
It's saying here just for security performance, this modem Windows only runs Microsoft verified apps.
Which app are you trying to use?
The CMD. The command.
CMD is a Microsoft app.
Yeah, I don't know why it's not working.
Just say yes. Oh, you probably do not have the admin rights. You are probably logged in as a guest.
Can he use command line on the thing, or he still wouldn't be able to?
He will have to log in as an admin. Every one of you should be admin of your machine. So it looks like you are, or come see me after class and I will show you. So here, the very first, guys, I'm going to give you some commands here. So very first commands, right? So first thing what we want to do is, this is a command line utility. Now, are we all familiar with Windows? Anyone who is not familiar with Windows? You are not familiar with Windows? Which machine that you use? MacBook? Okay. So are you familiar with MacBook? Okay. What is so good about Mac? No, I mean, you are a Mac user, right?
And then I use next week for.
No, I understand that, you know, it's up to you. But I just like to know what is so good that you like about Mac? It being more expensive? So I can tell you what is the good thing about Mac.
Okay.
The good thing about Mac is it is using the combination of Windows and Linux together to make up the MacBook. Okay, so a lot of good things about Mac, a lot of good thing about Linux is already part of MacBook. A lot of good things about Windows is already part of the MacBook. Okay, the operating system, the OS operating system, is that OS? What is that called? iOS, right? iOS operating system has both of them. So you are a Windows user, right? Why do you like Windows?
Because it's easier.
Because it's easier, user friendliness, right?
Yeah.
And then I can change the color, I can see the pop-up menu, I can so many drag and drop kind of things. Now, if you ask any of the Unix user why they like the Unix, is because they say, I don't have to deal with many things. I can just, if I know the code, I can do tuck, 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 and then everything is working. So it is bringing, the MacBook is bringing the fastness of the Linux as well as the good things about the user friendliness, the pictures, graphical user interface, security, all the different things from the Windows. So if you are the MacBook user, I think you have to use control space. I think there is a control, right? Control key plus a space, and then you type in terminal. So if you type in terminal, you will open up a command line utility like this. So first thing what I want to do is, I don't like all this junk here. I want to clear out my screen. So to clear the screen, just type in CLS. If you just type in CLS. Now, as soon as you type in CLS, it cleared the screen. Yeah? And then what I want to do here is, I want to go back to the topmost directory. So in here, if I start looking into this C, and then there is a users, and then there is a contact something here. So if I want to go back to the topmost directory, I can just type in CD /. So let's try this. CD /. And then it will take you to the topmost directory. Now if you type in CLS again, it will clear the screen and you get the whole screen for you. CLS. Yeah? So if you want to clear out everything, the best thing that you can do is you can type in CD and then /, that will take you to the topmost directory and CLS. And I want you to type IP config.
Config.
IP address configuration. It's the short form of your IP address configuration. So if I type IP config now, I am seeing this because I'm connected through the wire, but you are seeing a bunch of these where it is showing you the wireless IP address. Do you see that wireless IP address? So it looks like our network is this. Okay, So if I'm looking into Mohit's IP address, I have 192.168.50.78. Anyone know what is the IP address you have?
The last will be 39 first.
39. What about you guys?
172.
172. Anyone else?
200.
46?
45.
45 and 46 and 200.
Yes, sir.
Anyone else?
280.
218.
241.
241. 223.
253.
253. Now, if you start looking into this, none of us have the same IP address. Is that true?
Yes.
Okay. What was our IP address?
So now it was 1.212 million.
100.
If I start looking into what is my IP, so 98,
0.2.
yeah, so 98.200 or 212
Dot 42.
dot 42
Dot 100.
dot 100, right? So this is my WAN. WAN is given to the router, and router is using 192.168.1.1 for itself, and then it has assigned 78 to me. It has assigned 39 to someone, 172 to someone, 45 to someone, 46, and then 253. It has reserved one for itself, and then it has assigned all these IPs to everyone, and then it has reserved the 255 for itself. Do you see that now?
Yes.
So this is the WAN. This is using NAT, and then I'm getting local area network. This is the wide area network, right?
Yes.
So here is my internet, and here is my internet. So what exactly it is doing? It is using the NAT technology to bring up this. So here, this IP address is given to NAT. NAT converts that into this network, and this network has given me 255, out of which one is reserved for router, 255 is reserved for broadcasting. That tells me that I have up to 253. So somebody has .2 and somebody has .253, and most likely if there is 254 is in use, somebody actually has 254 as well, but nobody can claim that I have one or 255. What is the IP address that you got?
102 at the last.
102, right? So to get the outside IP, what is the easiest thing that you can do? If you want to see the Comcast IP address, what is the best thing? Just open a browser, what is my IP?
What is that?
Yeah, and it will tell you what is your IP. And then if you want to see the local IP that is assigned to you by your router, what do you want to do?
Wait, you said you want to what?
What we just did, man.
If you want to see your local IP, this is a public IP.
You go to myip.com?
Yes.
Okay,
This is my public IP.
but if you want to see your own IP.
Your own IP like this, what do you have to do?
You IP config.
Yeah, so you open the command line and then you just type in IP config.
What about if I want to see my MAC address like you said?
I'm telling you,
Okay.
you are ahead of me.
Sorry.
Okay. All right. So now let's see if we can find out our MAC address. Okay. So here I'm going to clear my screen one more time. All right. Let me delete this.
So sir, like everybody is right here is getting like a different IP, but you have like only one main IP, but we are getting like everybody's different IP.
Exactly. So your router will make sure that everyone internally is given a separate IP. Okay. But but outside it is only one IP, public IP. Now, if I want to see what is my MAC address, IP config /all. If you do that, where it says the physical IP is your MAC address. So this is your media access control address. This address will never change.
No. Why? Like, what is the reason?
This is your social security number of your computer.
Oh, MAC.
MAC media address.
IP config
/all.
/all.
See here. So I'm saying IP config. Don't show me the short version. I want to see everything. /all. So now it is telling me my computer name, right? All these different things. And then if I'm using the Wi-Fi or versus if you have 3 connections, you have a Wi-Fi, you have another the port, then it will also see each connection has a MAC address. And your MAC address is your social security number. So if you go to Comcast, if you go to any other place, a public networking, a library, Starbucks, your IP address will change. Look at this. This will change, but this will never change. Try it next time. Take a screenshot of this, and then when you go home, look at this. You will see a different IP address, but you will see the same MAC address.
Does all MAC address look like that? Would it be like the way?
It could be different as well.
Like, you know how it says like there's like 2 codes for each?
Yeah. So MAC address. So here you mean these here dots?
Yeah, the way that
You can sometimes I have also seen columns.
Okay.
Okay.
Okay. Oh no, not the columns, but like, for instance, it has two sets of numbers before they switch. Is that how it's
Yes.
Okay.
So format is like this, correct? However, can I say this is my IPv4 address? Yeah?
Yeah.
But what about this one?
Wait, for which one? The
IPv6.
IPv6.
Now look at this. IPv4 is really simple, right? 4 set of numbers. Here, look at this. It is using alphabets as well as the special characters as well as the numbers. Using that, it can generate 400,000 different 400,000 billion different IPs. It's a very powerful tool, and in the future, that is what they are going to look for. Okay. Now, I want you to clear this screen again, CLS. And I want you to type ipconfig now.
So how do you clear? See?
CLS. Remember CLS.
Windows CLS?
No. CLS. So remember, Windows key, right? Windows plus R. That will open up a run box. This is called a run box. And in the run box, I want you to type CMD and you hit enter. Okay. So the first command that you want is CD /. It will give you the complete window. And then you type CLS to clear the screen. And then you type ipconfig to get the IP configuration. If you want to see all the MAC address and everything that it offers, then you type ipconfig /all. If you want to find out what is your host name, what is your computer name, just type in host name and it will give you your host name. So if you just type in host name and it will give you your computer name. Okay. If you type date, it will give you the current date. It will ask you no new date, but don't just hit enter and it will stay consistent. Now, I need your attention here, okay? So this is your IPv6. Since we are not talking about IPv6, we are not going to look into that. Now, there are three different things that are for our interest, right? The first thing is your IP address. The IP address that is assigned to you. And then the last one, where it says the default gateway, is your router's IP address. Router's IP address. So just looking at this, I know my network is this. And this is telling me that one is for router. And it can go up to 255. And we know that 255 is our broadcast. That means I am somewhere in between. And as you can see, I am .78. You see that? So the default gateway, the terminology, the default gateway is nothing but your router is going to use this IP to send your traffic to the outside world. So when it is going outside, it is going through this network. So your laptop is here. Okay, your brother's laptop is here. Your sister's laptop is here, right? You all are connected to the default gateway 192.168.1.50 or sorry 50.1. And then you have .4, your brother has .47, your sister has .123. You all are communicating with each other through the internet, through the router. But if you need anything outside from the outside world, then you are using this as the default gateway. You are not sending this. So if I have to go to the internet, I'm not sending directly to the internet. I have to send it to my default gateway, which is the router, and then router will route your traffic to the internet.
So the default gateway routes everything to the internet?
You can say in a yes.
But it also gives the main IP address to connect to different.
It will form something called packets, and I will talk about that later.
So it's like a connection.
It is. Remember, if there is a bridge, you are on the east side of bridge and on the west side of bridge. So if you want to buy something from the east side of the bridge and you are in the east side of the bridge, so do you need the bridge?
Yeah.
No, you don't. If you're on the east.
If I'm on the east and I need to go to the other side.
So look at this, right? Let's say you are here on the east side, right? And then you want something from this person. So you're just going to communicate with this person. You don't have the bridge in between.
Oh yeah.
But if you need something from the west side, then you will have to go here. So this is your default gateway.
And you would need it to go from wherever you.
Yeah, so your bridge is needed in order for you to go. So your west is nothing but internet. And here you have the intranet. You need something directly from this side. If I need something from the other side, then I have to use the bridge. The bridge is nothing but your default gateway, which is your router.
And the router is the default gateway.
Yes, that's what I'm saying. So the default gateway, every time you see the default gateway, it is nothing but your router's IP address. Now, how can I find out if my router's IP address? Well, it is giving me 192.168.50.1, right? I'm going to copy this. I'm going to open up a new browser. And let's see if I can hit my router. 192.168.50.1. As soon as I do that, and I see that I have a router which is from ASUS. So let's see if I can. There you go. It is asking me.
So when you type in that IP address will take you to your ISPs.
To your default gateway, which is your router.
Okay.
So now if I'm the network administrator, then I will log in and then I need to do whatever I need to do on the router. Can you all hit this page? Let's see, 192.168. So our router address is what? 192.168.50.1. I want all of you to open up your browser and then type 192.168.50.1. Do you all see the same page? So your default gateway is 192.168.50.1. Wi-Fi is front right and that's the password.
For the 5G one or for the?
It doesn't matter. Either one is fine.
That's for Is that what you want us to sign into?
The default gateway. You don't have the credentials to sign in, but do you at least see the page?
Oh, the router account, all right?
Yes.
Oh, that's what you just
Yeah.
want to
See,
Oh.
yeah. So when you go home, just open up the command line utility, type in ipconfig. This is your IP that is given to you by your home network. And if you want to get to the router, you use this default gateway. You take this, put this in the browser and hit enter, and it should give you the page where you can log in to manage your router. Make sense?
Yes.
So we know this part. We know what is this, but now what exactly is the subnet mask? This is where I'm going to focus now. Okay, so let's say your IP address is 192.168.1.1. So we know this is the router. So this is your IP address. And here is the subnet mask. And subnet mask is 255.255.0. And your default gateway is 192.168.1.1, and then this is 17, for example. Now we are going to focus only on these three numbers. Okay, if I see that these three numbers, what that tells me is I can only, where it says 0, this is the only that I can grow up to from here to 255. What that means is only the last octet here is allowed to change. This 255 I cannot increase to 191. I cannot reduce to 191. I cannot increase to 193. Okay. This one says I cannot increase to one. I cannot decrease to any other number. I cannot change any of this number. You don't change anything. You don't change anything. So basically 255, 255, 255. I cannot do anything where the 0 is. I can change only this octet. I can change from 1 to 255. Does that make sense?
Mm-hmm.
So if I have the subnet mask, of 255, 255.0, this is called class C network. I'm only allowed to change the last octet. Does that make sense? If I see the subnet mask .255.255.0.0, what does that mean here now? I'm allowed to change this to 255. I'm allowed to change from this to 255. Does that make sense? Yeah? Okay. So now, if I have to name this, this is called class B network. During the meetings, you will actually hear a lot of this: class A network, class B network, class C network, and so on. Then I have another one, which is subnet mask 255.0.0.0. What that means now is I can go from 1 to 255 in the last octet, 1 to 255 in the second last octet, and then 1 to 255 in the third last octet, and these are called class A network. Now, in class C network, how many IPs that I can have? 255, and then basically minus 2, right? Okay. So here, in class A B network, how many IPs do you think I can have? Class B, 4. So 1 to 255,
Yeah.
and then 1 to 255. Can I say 255 times 255?
Yes.
So 255 times 255. I'm going to remove this because this is obvious, right? So here we have 65,000 IPs. So in each network, so 255 times 1 here, so I can have up to 255 IPs. In here, in network class B, I can have 255, 255, which is 65,000 IPs. Now, if I start looking into this, I can have 255 here, 255 here, 255 here. So what that means now is I can have 255 times 255 times 255 IPs in each of this network, which comes to 16 million IPs. In each network can have up to class A or class C. This is class B, and then this is class A.
So class A, you can just say, like, it's safe to say just do like 255 to like a third.
Let's talk about the smallest class. Let's say you are setting up a network in your home.
Yeah.
Okay. Which of these network do you think you will need? Do you need 255 IPs are enough for you? Or do you want to have 65,000 IPs at your home? or do you want to have 16 million IPs at your home?
Class C.
Class C. So industry standard is if it is residential, right?
Yes.
It is Class C all the time. If it is a mid-sized business, for example, any new e-commerce company, right? I just started a online store. So in that case, 255 is going to be too less for me.
Yeah.
Maybe I need to have up to 2,000 IPs. So will I select Class A, Class B, or Class C?
Class B.
Class B.
Class B. Class B is what is for mid-sized companies. But if you are Google, what do you think you will have?
Class C.
Class A.
Class A. Right? So here is the corporation. Similarly, there is an industry standard for any Class C, start with 192 and then whatever the set. For Class B, they say 172. For Class A, 10 dot. This is the industry standard. That does not mean that it is always true, but they say that if you are a residential, when you go home, you can actually see that. Most likely you are in 192 address because you are a residential. And then 172 is for a mid-sized business, and for a corporate environment, it is most likely the 10 dot address. So 10 dot, as soon as I see 10 dot address, I see 16 million IPs in general. As soon as I 172, I see 65,000 IPs. As soon as I see 192, I know it consists of 255 IPs.
So I don't understand this first one, like why we can't change that.
You can, it's up to you.
Like IP address, the subnet default gateway.
Okay, which one? This one here?
Yeah.
This is our class IP network, right? This is the class network. Class network at Moy IIT in Bolingbrook. So when I did the IP config, I got my IP address as 173 or 178. So it tells me the first thing that I'm going to always look for, not the IP address, not the subnet mask, I'm always going to look for the default gateway. This is my router's IP. Right? Now at this point, I'm going to say how many IPs my router is assigning to me or to this network. And as soon as I say 3 of these, then I know immediately this is a Class C. Class C by default can offer only up to 255 IPs. Because I see I can only grow from here to here. Last octet I can grow here. Can I go below 1? No. Can I go above 255? No. So the only number of IPs that I have is set of 255 IPs that I have to play. So can I say this is 255? So this is Class C. But instead of this, let's say I have this. 0.0. So the last octet can grow from 1 to 255. Is that true? If I need more IPs, can I grow this to 1?
Yes.
Yeah. So, can I grow this different IPs? Yes. So from here to here, again, I can start growing from 1 to 255. That's why if you multiply 255 for 255, each network can have 255 IPs. And then you will get something around 65,000 IPs. And this becomes a Class B network. But my limitation, my router can only have 65,000 IPs. but my business is growing. 265,000 IPs are not enough. So in that case, I will change my subnet mask to have 0. It means if I start looking into this, I'm in the class A network. Class A network, I start with this, it went up to 255, then I start with 1, 2, 3, 4, it went to 255. Now I can grow from 1 again to 255. Now in the class A network, 255 times 255 times 255, you get 16 million IPs in each network.
Then why we into for 3 times? 255, 255. Like, what is the reason behind this?
Do you understand this part here?
Yes.
Okay, what does this mean here, this box?
So it seems like we cannot like go more than 1 and lower than the.
Lower than 1 or higher than 255?
Yes.
So how many IP addresses that I can get here?
253.
253 usable,
Yes.
but in general, how many IPs?
255.
255. So once I need 256th IP, what do you have to do? If you have now the computer number 256 came into your workshop, you have to assign an IP, but your limitation you have already maxed out. What do you have to do?
Class B.
Here you will change this from 255. So earlier it was like this. Yeah? So here I was saying I can only grow from here to here. But if I change this to 0, now I can start a new IP 1.1, 1.2, 1.3, 1.4, 1.5, 1.255. Then I can grow this to 2. Then 2.1, 2.2, 2.3, 2.4, all the way up to 2.225. Then if I still need more, I can grow 3, 3.1, 3.4. How many more I can grow? Up to 255.1, 255.2, 255.3, and then 255.255. So 255 times 255 computers, because in each network I can have, so for example, network 1, 192, 168, 1 dot, in here how many computers that I can have?
255.
So I'm going to name this as network 1. Okay, my network 1 offers me how many computers? Then I need a new computer. Then I say 192, 168, 2. I'm opening up a second network. This is network 2. So how many more computers that I can add?
255.
Up to 255, right? So can I say 255 times 2 is number of IPs that I can have?
Right.
510 IPs. So the more networks that you are creating, so if I create the third network, then I say 255 times 3. If I create the fourth network, I say 255 times 4. If I create 100 network, then I say 255 times 100. If I create 200th network, I say 255 times 200. If I am at the last network, 255, can I say 255 times 255? So this is the max in subnet or the B class, class B. So if I need more than this, then I have to change this octet to 0 now, which can start offering me from 1 to this again.
And when is one like 256?
Why?
Like you told me earlier, like if we have like 256, then where is it?
Okay, so network 1 is offering me 192, 168, 1.2 all the way up to 253, right? 1 it is keeping for itself, 255 is reserved. Now I have another computer, another 10 computers that I want to add. Then their IP address would be 192, 168. Because I'm done with this, I will start with 2. 1 is reserved, and then 255 is reserved. My computer number 1 will get 2.2, then 2.3, 2.4, 2.5, and then 2.12. Make sense? So if I need more computers after my network, I'm going to go one network below, and then I can start networking.
Quick question. So when we have an implementation project, right? And when it's a multitasking project, does a technical consultant actually configure these numbers by default, or are they in the threshold,
Your
assigned?
network admin will have to do that.
They will have to.
As DBAs, we don't have to work on any of these, but this is just for your understanding.
Yeah.
If you're in the meeting, they're talking about class C, class B. If they say 10 dot network, immediately you know that they're talking about class A network, where they're talking about 16 million IPs. They may say 255.255.255.0, and then immediately you know what is that? Is that a subnet mask? Subnet mask, that means last zero is giving me 255 IPs. Every zero is giving me 255. All I have to do is just multiply it, and then I get my number.
And these numbers are like exact fixed numbers, like 192, 170.
No, like I said, this is in general. In general, the rule that the networking the networking community, what they say is, in general, if I see 192, this is residential. In general, if we see an IP address, if you go to Starbucks, for example, you may see an IP which is 10.15.16.17. Okay, and then you see subnet mask is 255.255.0.0, and then your IP, your default gateway is 15.18.13, okay, or 18.1. Now you may say, hey, you know what? Look at this. I have 17 and 16, so I was expecting 16.1 here, but I'm not seeing 16.1 here. I'm seeing 18. Why? Because this 16 can also grow to 18. Is that true?
Yeah, that is true.
Because I have the 0 here. What that means is not only this line is increasing, this line can also increase. If I look at this, I know immediately this Starbucks is giving about 65,000 IPs.
Because any numbers which are not used are available within the system by default to be assigned.
Yes.
So I have a question over here. Let's say we go to Starbucks, so we get the same IP address every time, or every time it's going
I'm actually getting there. But before we move into the next step, now, you know, if you take a networking class, the topic that we just covered may take weeks for you to get into the tiniest detail. But we are not going to be network admins. I'm just giving you some of the keywords so that you at least understand the basics. Okay? So if you understand this part now, we can move on. If you have any question, this is the time to ask.
Sir, if we had the class C networking, like subnet market, after that, after C, we need the class B. So we change the network, or
Yes.
we need the new
Yes.
connection?
Yes. So I will have to log into my network, into my router, and I will have to change my subnet from 255. So if I use this, I cannot have the 256 IP, period.
Yes.
I will have to disconnect someone to make someone happy.
So we buy the new connection, or we do
No.
it by
You just log into your default gateway, right? Your default gateway is your router. And then you go to the subnet mask section, and then you change from this to this. That's it. And it will allow you 65,000 IPs now.
So you just add another 0 to it, right?
You change this to 55 to 0.
Yeah.
But
And then there are a bunch of other things.
you will always have in abundance in the subnet mask. You will always have.
Your network admins, they are the one who takes care of it. But for your own configuration, when you go home, you can play around with this.
Yeah.
Can I erase this now?
Yes. Yes.
Any questions? No questions?
So
Okay.
can I take one picture if you don't mind? Sorry.
Yeah. So let's look into the router now. Some of the router's properties. Okay.
Sir, we will get this as a video, right? From Jelly Party.
Yeah, he charged you $10.
Yeah. Please.
Yeah, you can use it.
So we will have like for 1 week, right? The video.
Yeah, so the videos will go offline at around 11:59 on Friday. Okay, so you can pause, you can make notes, you can do whatever you want, you can rewatch. All this, the entire class is shared with everyone. It is now, right?
Yes.
Okay.
And so these videos will be in the Google Classroom, am I right?
Yes, if you are not part of the Google Classroom yet, you need to join.
I did.
And then if you do not know how to join, look at the description of the WhatsApp group. You will see the Google Classroom code and you will see the URL as well. And then you can simply join. I think I have already added majority of the students who signed up late.
I'm not.
Okay. Anyone who has signed up late, that they may be not added. So look at the description. You are added to the WhatsApp group.
No, I'm not.
Okay. So send me a message on WhatsApp, both of you. Whoever is not added to the group, send me a message on WhatsApp, and then I will add you. So we already know what is a router. Router is basically a device, a physical device that routes. Router routes from one IP to a set of IPs in a network or networks. Okay. So the property of router is it has the WAN port, and then it has LAN port. LAN port is connected to the ISP. From ISP, it is connected to the internet. And there may be bunch of hops in between. Right? So this is your home network. Now, if I have a computer here, wired connection, computer A, right? Another wired connection, computer B. Another wired connection, computer C. And then now I have the printer, printer 1. Yeah? And then I may have another printer here, printer 2. I have another TV here, TV 1. And then I have 2 different ports open. And then I also have this capacity. So the router is taking the WAN IP, which is 9.8.7.6. Internally, it is converting everything to an internal, which is 192.168.1.1. It is keeping for itself. And then the computer 2 has an IP, different IPs in here. So let's say if this is my router, okay, the router engine, it may have a database sitting in here. Okay. Router is trying to keep, so in the memory, it is trying to keep a bunch of things in here. What it has is nothing but, think of this as a spreadsheet. Okay. So if I start zooming this, then it will say IP number 1, I'm going to keep for myself. The host name is router, and purpose is routers management. Routers management. And then the IP address is 192.168.1.1, and it will say this type of connection static, and we will talk about that static. And then it will also have what is the MAC address associated with this MAC address. So if you have ever worked with a spreadsheet like Excel, right, you will know. So it has all this, the header here, and here it is saying what is the MAC address, and then it will give you the MAC address bunch of this type of configuration static, and then this is the IP address, and this is the reason, what is it needed for, and name, host name, and here is the number. So for 2, it will say, oh, you have assigned this to printer 1. So .2, I will say printer 1. Printer 1, here's the printer and printer at Mo's office. And then it will give 192.168.1.2. And here it will say static and MAC address, whatever it is. So if you start looking into this, it has the MAC address and IP address of each of these devices. Okay. So I have the IP address table that is saved in here in the router. Okay. Now we start seeing some of the wireless networks. So I have a user here, I have a user here, I have a user here, and I have a user here. They all are connected using the Wi-Fi. Okay. So now you will start seeing, and then let's say this guy has .51, .52, .53, .54. So here you will start seeing this. Whatever the line number, whatever this, you will see 192.168, 1.51, and here you will say dynamic, and here is the MAC address. The same thing for the other guy. Blah blah blah, all this information, 192.168, 1.52, and again dynamic, and then you have the MAC address. So basically, you understand this is the sequence, this is the host name, this is why we are needed, the IP address, and then here is the type of connection. It's either static or dynamic, what exactly this is. And then every IP has a MAC address that it is also collecting. When I say static versus the dynamic, a router has the option. Router will say, if you are using a wired connection, for example, for servers, we want to give static IPs. Static IPs are managed by humans. These IP addresses do not change, right? So for example, I have assigned a static IP of 1 for router, static IP for 2 for printer, and so on. Static IPs do not change. Do not change. And here, for clients, for PCs, these are the dynamic IPs.
So if it's connected wired.
Router management, router manage IPs. May change. What do I mean by may change? Now when I come back tomorrow, then I will see my computer IP will remain same. But there is no guarantee that you will also have the same IP tomorrow. What is the IP that you received earlier? What was the IP? 192? 192 was the IP, and then some of you have .36, some of you have .42, right? So what I'm saying is, when you come back tomorrow, router will try to give you the same IP that you have used today, but there is no guarantee. The reason it is not providing you the guarantee is, for example, my later class is bigger than this class, and router does not have enough empty IPs, then it will take out an IP of one it has used earlier and then give that IP to someone else. So what it is doing is it is cycling IPs. It will try to keep your IP bounded with your MAC address for up to a certain amount of days. That certain amount of period is called the leasing time. Okay? Every router has the leasing time. This lease time by default is 7 days. So what it is doing is every IP is mapped to the MAC address, and it will try to give the same IP to that MAC address for up to 7 days. So you come back tomorrow, your leasing time has not expired. But when you come back next Saturday, it may have expired already. So you may get a different IP. Or let's say there is a power outage. My router went down. As soon as the router end goes down, it erases all the dynamic, but it will keep the static, because when it comes back up, it will have to start assigning the same IPs to the same servers where the humans are managing. But your IPs here are removed. All your information here is removed now. So it may give you, next time you log in, it will say who, so you have 136 today, the next time you log in, you may get .17. Why? Because there is a power outage. So the router went down, router came up. When router came up, the #1 priority is to give the static IPs back to the same MAC addresses it had before. But for any of the dynamic, it's all erased. Then it will start fresh. So you get a new IP. Yes.
It's only wired devices or only static?
No, you can have so in general, only the wired or the servers where I'm keeping pictures, music, my confidential data, anything, web server, database server, we don't want their IPs to change, right?
Yeah.
So we want them to have a static IP. Static IP is guaranteed IP that the same machine will get the same IP the next time. Even if that machine comes up after 4 years. If the router is still in place, it will assign the same IP to the same machine. Why? Because it is saving that machine's IP with the MAC address. Because the MAC address does not change, it will assign the same IP to that MAC address. But the same is not guaranteed for the dynamic IPs. Dynamic IPs is not the one that I control. When you come to the class yesterday, right, or today, you saw the IP address, so you saw the password here, and then you log in. Did I assign the IP to you?
No.
Machine did. So you have a dynamic IP. But that computer there, it is wired connect, and I said do not change my IP address. So that is a static. So if there is a power outage today, that machine will get the same IP, but your machine may get a different IP.
Even if you disconnect it, right?
Even, yes. So the lease time, every router has something called a lease time. The lease time is 7 days by default. But if your network admin decides that he wants to have lease time up to 360 days, he can do that. So for 1 year, your IP is bounded together. However, there is no guarantee. If it needs that IP to cycle, then they will say, okay, let's get rid of this and then give this to someone else, instead of having that person to wait. Any question on this?
So I have a question. So how we can make our connection static? Do we have to do it, or is it just like?
You can do it as well, but it is not a good idea, because if it is at your home system which is wirely connected, it is a good idea. But if you do this on your laptop, you may set it as static IP here, but if you take it around the world, every IP address is different, so it will stop working. So it is not a good idea for a laptop. It is a good idea if you have a static server at home. So I'm just going to give you a small demo on how you can change your IP address to static. But if you do not know what you're doing, don't do it. Otherwise, your laptop will stop working at home. It will only work here. Okay? So if you just type in There are multiple ways that you can do that. 1 second. So on your network, any network, right? So if you click on if you search for network, and so open and then search, right? In your search bar, you just type in network, and then show all available network or whichever. So right now I am connected to this one. That you may have a wireless one here. So just click on the properties. Okay, and it will have all this ones here, and you can see then this is an automatic, which is called the DHCP, Dynamic Host Control Protocol. If you edit this one, I say manual, and then it will give me IP address. Now I have to give all these IP addresses. So I will say 192.168.1.51. I always want this, and then the default gateway is 192.168.50.1. 50.1, and then I just click on save. IPv6 I don't need it, so it will only generate this one. But I suggest do not play around with this if you are on your laptop. Okay, so let's say we have a very simple configuration, no internet, or let's say we have internet here, right? And you have two computers connected. I have one machine, user A, and then I have another machine here, user B. My network here is 192.168.1.1, and then this one is assigned 192.168.1.51, and this one is assigned 192.168.1.52. Are we okay so far? In between here, I have a server. This server is hosting all my MP3s. So now I can say, I can send a signal. I know that I have an MP3 called a.mp3 into a host. I have this as server A. Server A. Okay. So what I can do is I can send a request. Hey, default gateway, I want you to go to server A and then get the a.mp3 to me. The request is being sent. Request is sent to default gateway. Default gateway is your router, right? So your packets, we will talk about the packets later next week. So it reaches here. Now, how does your router, and let's say this is the first time, this is the first request your router is getting. We just started. Router is connected to the internet and router is connected to the local area network as well. So here, a user has requested go to server A and download a.mp3. Now let me ask you this, how does the router know that it has to send this to the outside world or inside world to request? Router can do both ways, right? It is search internally, it can search externally. This is your internet. How does the router know where to search? Or do you think it will start searching both?
It will search through the server, right?
Okay, forget about the server. Maybe let's say this is another machine, laptop here. Okay, so there is laptop here. So this one is called laptop C. This is where I have a.mp3.
It'll search through the IP address?
Okay. So first of all, there is no IP address. The user says, I don't know what is the IP address of server A, or in this case LC. Okay. I don't know the IP address of LC, but I know the LC hosts a music file that I want to search for.
So if it's in the computer, then it's go to intranet, and if they are asking for somebody else, like let's say if I need you to send me this file, then maybe we can go to intranet.
Okay. So remember, all router has to manage this, right? Router is accepting the changes or accepting any request, and it is rerouting. You go to the internet, you go to the google.com, you go to the local intranet computer and so on. The router is routing. So what I'm asking is, how does the router know how to route? How does it know that I have to send this request to find what is LC outside or inside? Should I ask, hey, is there a LC here? Or should I ask, hey, is there a LC here? By default, as soon as it gets the request, right? What it does is, it says, wait a minute, I am going to broadcast this message. Who is LC? So it is going to send a message here. It is also going to send a message here. When this computer receives that message, it stays quiet. Says, hey, I'm not LC, so I'm not replying. This person says, hey, I am LC. What do you need from me? So this will reply. As soon as it replies, your question is sent to this computer. So in simple terminology, can I say a router, every time it does not know where to send, it broadcasts?
Yes.
If I have 25 different systems in my intranet, it broadcasts to 25 different networks or 25 different IPs in here. Who is LC? 24 out of 25 is not going to reply. The only person who's going to reply is that system. Does that make sense?
Is it by default?
This is by default. So this system where I'm broadcasting, it needs a separate IP. That's where the 255 comes in. You remember I said the one it is using for itself, and then 255 it uses to broadcast.
So this is not default gateway, or this is default gateway?
This is the default gateway, right?
Okay.
So by default, it is internally asking for who is LC. Let's say there is no LC here. Or the requester says, hey, go to YouTube and get me this file or this song or this movie. Now it is going to broadcast, hey, who is YouTube? There is another system sitting here. This guy is the requester. This guy say, I'm not YouTube, I'm not going to reply. This guy say, I'm not YouTube, I'm not going to reply. And after, so let's say there are 25 different systems here. Everyone is going to, nobody is YouTube, so nobody is going to reply. So in that case, it uses the .255 to talk to this one. Are you YouTube? 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 Nobody is going to reply. So in that case, it will forward that to the internet. And then internet will say, who is YouTube? Hey, I am YouTube. So now it will forward this connection to the YouTube, and then YouTube will send the request back to the user, and then the user is happy. Does that make sense?
Yes.
Is this a cloud-based setup as well?
It depends on if the network is on. If they have a blocker here, it will never go to internet.
But if it's a virtual dedicated server which has files, and whichever commands they use, they will retrieve the files.
Yes, it depends. Yeah, it depends. If you have the files locally hosted, it will not use the internet traffic.
I see.
If it is outside of your network, then it uses the internet traffic. That's why the companies, they don't like to put the financial data on cloud, because they may have some SQL injection or somebody sniffing data or something. They want to have their own dedicated firewall. Okay, make sense?
Yeah.
So let's just recap of what we have talked about so far today. Or actually, before we do that, let's cover one more thing. So here is your router, right? If your router has 4 ports, 1, 2, 3, 4 ports, and there is one port which is the WAN, and I have the port 1, port 2, port 3, and port 4. Now I can have many different wireless connections here. So I connected for port 1, I connected one computer. For port 2, I connected another computer, right? For port 3, I connect another computer. For port 4, I use another computer. Now I have 5 more servers that I need to connect, and they're all wired. What do you think I can do here? This is my router. I have 5 more new systems sitting in my warehouse. They have to be on the network. They cannot be on Wi-Fi. They have to have the physical connection.
Oh, physical connection?
Physical connection. So I already have used all the 4 ports here. I have 5 more sitting.
A patch panel? A patch panel? No?
What I'm going to do here is I am going to take one of these systems and then add a switch. Okay? A switch is nothing but an extension to a router, a physical extension. This switch may have 8 different ports now. So this computer got .2, .3, .4, right? This port here can use .100, and then the .5 is here. .6 is here. .7 is here. .8 is here. .9, right? At some point, .10, your business is keep growing. .11, and now I have 5 more systems sitting now. What do I do?
Again, switch.
Again, I can add another switch here. So this time, I'm smart enough to get a bigger switch.
0.200 would be the name.
Exactly. So here, I'm going to statically give .200 for this one. So the first switch is using .100. The second switch is using .200. Now this switch, the first one was 8 ports. The second one was, the first one was 4 ports. The second one was 8 ports. Now I can go up to 62. So 1, 2, 3, 4, 5, or 32. 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? 15, 16, 17, 18, 19, all the way up to 32 ports. Now each of this, I can add another computer. So I will say .12, .13, .14. Now if I start looking into this, I still have many ports open to connect to new systems. Yeah? So my router IP, if my router, which is the default gateway, is, let's say 172.15.16.1. Yeah? So now it is saying I'm going to keep 172.15.16.1 for myself. Routers management. Routers management. And here I will say 255 for broadcasting. Internally, .100 is for switch 1. .200 is for switch 2. Okay? And here I can say from here to here, use all the dynamic IPs. So any computer that needs a wireless connection, a new user who comes into the office, they're always going to get between 201 to 254. And I can keep all of these as static. So dynamic IPs has a name which is called DHCP, Dynamic Host Control Protocol. So here a human is giving the IPs. Here machine is giving the IPs based on the need. Make sense?
Yes.
So if I have a small router which has only 4 ports, most of the time in a home we are not plugged in directly to the wire, right? It's gone wireless, so we don't care. But if it is a small business, they may say, I need to have this on wired because of static IP addresses, and so on. So I'm going to use one of the port for add another switch, keep adding more machines. When there is a need of new switch or a new extension, then I'm going to add another bigger switch, and then that switch will start assigning more. And then every router will have two set of IPs. One are called the static IPs that are maintained by humans, and these are the IPs that should not change the IP addresses. And then if you are a Starbucks, are you going to give them static IPs or DHCP? DHCP addresses, dynamic, because you may have one customer today and then he may not come back for next 6 months. So we are giving a default lease time, and if you are a public like Starbucks, I think their lease time is probably 1 day. It's not 7 days or 30 days. Or maybe their lease time is for next 60 minutes. After 60 minutes, you get a different IP. They have to keep controlling it.
For all the Zoom meetings, is that how it works? 45-minute lapse, and then the Zoom gets.
Some of it is controlled by that, yes. An extension to a router is a switch. And switch by itself, it needs only its own IP. That's where the .100, .200 comes in. The router has two different type of IPs that it needs to manage. One are called the static IPs, the other one are called the DHCPs. DHCPs are controlled by router, the static IPs are controlled by the humans, network admins. It is this now?
Yes. But despite the number of switches we use, right, the transfer of data doesn't get affected, right? Like the migration of data from one switch to the other based on the.
Let me turn on the lights 1 second. Now your question is, how is the performance going to be? Is it going to get slower? Is that right?
Static or bottlenecking or any such issue.
Yeah. So it depends on the traffic, it depends on various factors. But in general, a router should not have more than 20 connections. And you will start seeing slowness. So there are different variations that network admins use to control that. Okay, so I'm going to start from the back. I'm sorry, what is your name? Mohsen. What is one of the keywords that you learned today?
DHCP and network address.
Okay, so DHCP, what is DHCP?
Dynamic host configuration protocol.
Okay, dynamic host control protocol.
Assign IP address.
Okay. Okay, and I'm sorry, what is your name?
Yasin.
Yasin. So Yasin, how do you, tell me something about DHCP.
It's our
Who manages the DHCP?
switch.
No. Are you sure it is managed by a switch? Who manages the switch?
The router.
Router. So it is managed by router. Managed by router. Now, what is your name? Ida? Rida? Okay. So Rida, can you tell me a little bit more about the router? Anything that you remember? Can the router manage IPv4 and IPv6? IPv4. So router can have both IPv4 and these days they are also managing IPv6. So Rida, anything about IPv4? Okay. Salman, what do you think? Anything about IPv4? IP is Internet Protocol, right? V4 is version 4. So anything about version 4?
That'd be like 4.2 billion, 100.
Okay. Anything like the IP addresses, how many different sectors you see in numbers when it comes to IP address? So can I say there is the first part, the second part, the third part, and then the fourth part, right? Each of these are
Octet.
octet. So how many that you have? 4.
4.
Now octet can start with 1 and then it has to end with 255. 1 is router's IP, right? Which is the default gateway. And 255 is the broadcast. And basically it asks, are you there? Right? Are you there kind of messages. Umaima, tell me anything more about router.
It routes.
Okay, so router, whenever we are talking about route, it routes, right? Simple term is it routes. Now when you say it routes, what exactly is routing?
The IP addresses.
The IP address. So when I say IP address, yes, it is routing the IP address, but what IP address to what IP address?
From LANs to WANs.
Exactly. So WAN IP address will get changed to LAN IP addresses. LAN IP address will create a network of 255 IPs. What is this technology called? I'm sorry, what is your name?
Anna.
Anam. So Anam, what is this technology called where it is performing the conversion from WAN to LAN?
IPS.
NAT.
Yes.
Network area transition, right? Network area transition. Okay. Anam, anything about the router? So we got that the first property we see is it has the IPv4, IPv6. The second property, it routes the WAN into LAN and so on. The third property that we also see, it keeps one IP for itself. The fourth property we see is it keeps one IP for broadcasting. Any other property that you can tell me? Anything that you remember from our class? Subnet mask. Now, if I start looking into the IP's details, right? To get details of IP address. Now, there are two different types of IP address. The first type is the public IP. This is given to you by ISP, Internet Service Provider. Okay, so Internet Service Provider, if you want to find out what is the IP of that is leased to you, what is the quickest way?
The domain. What is my IP?
What is my IP address, right? What is my IP address? What is my IP.com? This is the quickest way. There are different ways that you can look into, but this is the quickest way. The second is the private IP. Okay. The private IP is managed by who?
The command line,
How do I find out what is the private IP?
IP config on the command line.
IP config. Now, when I talked about IP config from the command line, right? So you start this command line, CMD, and then you type in IP config. It does show me 3 different properties. IP address, subnet mask, and default gateway. So Anand, you said subnet mask, right?
Yes.
Okay, what do you expect to see here in general if you are at home?
Class A.
Class A, Class C. And how do we define Class C? 255.255.255.0. This tells me that this 0 can go from 1 to 255. Yeah? So if I see this one, I know the limitation. Limit is to have one network of 255 IPs. In this case, the network would be these three guys. Then I would look into the default gateway. What is the default gateway? Router's IP. So in this case, if I say 192.168.15.1 is my default gateway. And then the IP address again is either the static IP or the dynamic IP. And then most likely, since this is the network, I will see 192.168.50. Any number, 17, that is assigned to you. The last octet, the last IP is the user's IP. User's IP. User or machine IP, for example. Okay. For the subnet mask, what can you tell me a little bit more about subnet masks?
A little bit more. What can I tell you?
How many different classes are there?
3 classes.
A, B, C.
Network class. I'm sorry, I didn't get your name.
Nana. Nana.
Nana?
Yes.
You know what Nana means?
Yeah. I don't know.
Grandfather.
Father?
Grandfather.
Grandfather?
Okay, grandpa. So what is?
What is the what?
So now we won't forget your name.
Yes.
Nana. Okay. So you have class A.
Mhm.
What is class A in general for?
Class A in general is like maybe
Large
large
corporation.
corporation.
So here, this is reserved for mostly large corporations.
Mhm.
And this is going to have how many IPs?
Well,
Billions.
Billions.
One network. One network.
4.2
4.5 billion.
No.
16.
No, all IPs together are 4.2 billion. One network of class A, 16 million
16
IPs.
million. Oh.
Right? One IP. What that means is, if I have 10 dot, this is considered one network.
Yes.
So in these, I can have 16 million IPs. Okay, if I have a 9 here, then this is another 16 million. So each network can have 16 million IPs. If I go with 11 here, 11 can have another 16 million IPs, and so on. What about class B? Who is next to you? What is your name?
David.
David. So what is class B?
The mid-size?
Mid-size. Okay, so here, how do you describe mid-size business?
It needs to be like 65,000.
Any business that requires less than 65,000 IPs. So in this case, an example would be 9.10. This. So this, each network can have up to 65,000 IPs. So 9.11 is going to have 65 IPs. 9.12 is again going to have 65,000 IPs. Does that make sense? So in this case, one network is this. One network is this. In this case, one network is a combination of the first 2 octets. The first 2 octets. This is called one network. Then the next network, again 65,000 IPs.
I thought it wasn't it 172 point something to start off the IP for class.
Yes, in general, but that does not mean it's always,
Oh,
right?
okay.
So 9.10 is also a class B.
Okay.
Okay. And what is your name, brother?
Kelly.
Mikeli?
Yes.
Okay, Mikeli. So what is class C? Tell me something about class C.
It's a residential network.
It's a residential, okay? Residential. And how many IPs that you can get?
65.
No, 65,000 is class B, right? Class A is 16 million IPs. This
Oh.
is
50,000.
255 IPs. Yeah, so one of the example is 9.10.11. This can have up to from 1 to 255. So this is a network. Then 9.10.12 is another set of networks. Yeah, 9.10.13 is another set of networks. or set of IPs. So here, this is the network. Each IP can have up to 255 IPs. Make sense? So subnet mask, in this case, the subnet mask will always be 255.0.0.0. This is the subnet mask. In this case, the subnet mask is 255 times 255 .0.0, and you can see the network. Class C subnet mask is 255, 255, 255.0, and you can see the subnet mask consists of the three set of objects. Okay. What is the next? Okay, go ahead. 12:42. Okay, 8 more minutes is not going to hurt, right? Okay. So just quickly recap. What is the next thing? What is your name? I'm sorry.
Samir.
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 Samia. Okay, Samia, anything that you can think about from our class? Any keyword? Or you are in a rush to leave? Your ride is here? If your ride is here, you can leave. It's up to you. Come on, you're smart enough. You can tell me what is the next thing that you have, any keyword that you have learned in your class? What about you?
My name is Hira.
Hira.
Yeah, and
H-I-R-A?
yeah, H-I-R. And we
That's
learned
diamond,
about-
right?
Sorry?
That's diamond, Hira.
No,
Okay.
sir.
Now I remember you. Okay.
So we learned about the router have 4 ports. So if we connect the more computers to that router, so we need the switch.
Okay.
There is
So
extension.
router's extension is basically the switch. Router, and then you have the switch. If router is going to keep an IP 192.168.50.1, it will have to assign a static IP to switch, and usually something unique. Okay, what is the purpose of switch? Adding more physical connectivity to the network. What about you? What is your name? Mohammed. Okay, Mohammed, anything?
So we can like connect like more switches, like 4 to 8, 8 to 16, 32. So we can like spread the internet.
So you can have different configurations. So usually I see 4, 8, 16, 32. I have seen 64 ports as well, machines. Okay. Anything that you can think of that you can add?
There's a leasing time. Leasing time.
So every router has a leasing time, lease time, right? So every router has a lease time.
7
By
days.
default, it
Max.
is 7 days. But it will try to guarantee, but it will not guarantee you. It will say, I may be able to keep it, otherwise I will assign to someone else.
Who changes the subnet mask?
Network admin. So in your home, you are the network admin. So if you log into your router's configuration, there you will see the subnet mask, and then it will allow you to change.
Like you say that's legal, right?
That is,
Legal.
oh yeah, in your home, you are everyone. You are the president of the house, right?
So the company gives us certain, users to use. So if you go and change that, that won't be a problem.
You cannot change in your company. You don't have access. Remember, we just logged into the network portal, but I didn't give you the username password. You cannot log in. So you cannot change in your company.
Please do it.
Sorry? That's what I said. When you go home, you are your own admin, right? You can find different relation. And there is always a switch in the back to reset. So if something messed up, you can reset. Okay, that's it, guys. Inshallah, I will see you next Saturday. We'll get into some other details. Now, make sure when you come next week, make sure you have your laptop. If you do not have a laptop, do not bring MacBook. I'm not going to support. I know some basics of MacBook, but not a lot. Make sure you get the Windows machine.